So cotton is a perennial plant. It invests a lot of energy in developing that root system early on. It is a taproot, which allows it to basically anchor and go down deep into the soil to pull moisture and nutrients from deep down in the soil and use those to basically feed the rest of the plant throughout the season. The other thing is that, in order to keep this plant height managed, because again it is a perennial plant, its priority is primarily vegetative, and we kind of encourage it to produce bolls, but we use plant growth regulators to control the plant height or to reduce the plant height. So those plant growth regulators keep it from growing into a 6, 8, or 10 foot type plant that we can grow down in South Texas. So obviously we do that in order to try to keep plants at a manageable height so that we can increase our harvest efficiency. So as we move up the plant, we have our vegetative branches here that I've broken off, but these are all vegetative branches to begin with. And then we get up here to our reproductive branches, and we call these reproductive branches because this is where our first flower was formed. That flower has since turned into a boll, and then you can progress up the plant. The bolls progress up the plant, and they're about 3 days older as you move from this branch to this one, to this one, to this one. You can see they're decreasing in size. So again, that's one of the benefits of cotton, is it spreads its fruit over a time frame, which allows it to endure a lot more environmental stress as the season goes on. If we have a stress event, it may actually abort some of these fruit or bolls, and then when conditions are good, it'll start to put on more bolls again. As you move out on this branch, the reproductive branch, every 6 days, you would basically have a new boll here. We have a missing boll just due to either insect damage or something else, another missing boll, and then this one. So this boll out here would be about 15 days older than this boll here that's further down on the branch. Most of the yield that we get off the cotton plant is usually off these we call the first position bolls, so the first boll on each branch as you move up. About 70% of the yield, and that's because the plant can dedicate a lot of energy to those bolls along that main branch. So we can move up, we see the bolls are still here, and then we got up here to our first flower. So this is a flower that's been recently pollinated. That's why it's pink. Here we're missing a fruiting site. This would probably be a square. And then you can see the squares up here, which are the flower buds. So these are the flower buds on the cotton plant. And after, again, that one's probably another 10 days, that flower will actually open up, then pollinate, and then it will create a small boll, and then go on to produce a mature boll. And then you can see it working up where we have more squares up in the top of the plant. So here's a flower bud, one of the older ones where the flower is about to open up in the next few days. You can see that there. And then further out on the branch is another flower bud that's 6 days younger. That's right here. So again, in a few days, this will actually open up into this creamy white flower, and then it will make a white flower that looks like this. And then after it's pollinated, it'll turn into that, the petals will turn pink or red. And then after that, the boll starts to develop on the cotton plant. Here's a recent flower. The petals have dried down. The petals have actually stuck to the boll itself. They're the beginnings of a young cotton boll. And again, it'll be about 55 days before that boll actually opens up into, opens up and the length is fully developed and it's ready to harvest. So one thing that cotton does is under unfavorable or really stress conditions, it can actually abort some of the young fruit that's on that plant. And what it's trying to do is reach a balance between the amount of photosynthesis that it can produce and feed those bolls, versus the number of bolls on the plant. So we have had a string of cloudy days here in this field, and we see a lot of these bolls like this that are actually at the ends of the rows or down in between the rows, and those are fruit that cotton plant has actually shed. And again, you can see it's a small boll. Usually after these bolls are about 14 days old, it's not going to abort them, but those younger bolls it will. And again, it's basically to adapt to the growing conditions that it's actually dealing with at that point in time. And that's one of the things that does make cotton do well in a lot of the state of Texas, where we do have erratic rainfall and things like that. It allows that plant to adjust over time and allows it to go ahead and put on fruit when it has conditions are favorable, or wait, if they are unfavorable until favorable conditions do exist. On this example, this plant, we've been in fruiting for at least 4 weeks, and you can see the progression of the cotton bolls as you move up the plant. We probably have another couple weeks left before these plants are continue to fruit, and then we're going to reach a point where that cotton plant has put on enough cotton bolls that it can't really maintain anymore. And then what happens at that point in time is it starts to, the flowers continue to move progressively higher and higher up into the canopy. And we reach a point where, again, that plant's vegetative growth is all it can handle, is the amount of fruit that's on there at that given point in time. And then we will put up very little more vegetative growth and probably no more bolls at that point in time. So our fruit load and our yield potential is kind of set at that point in time. And I'm guessing here we have another 2 or 3 weeks of fruiting before we reach that. One way you can determine it is how far it is above the first position white flower. So just imagine that this is white. You count up the number of still nodes above. 1, 2, 3, 4, 5, 6. So generally we say when you get to node 4 or 5 above white flower, then that plant has really reached, we call it cut out. It means it's probably not going to put on any more reproductive bolls at that point in time. One is probably, I'm guessing, 75, 80% mature. We want to put a maturity rating on it. But again, it can, if we were to go through a stress event and lose all these bolls, which could happen under a stress event, and we'd have a blank here in the middle, it'll continue to have vegetative growth and then put on more fruit at the top. It's not uncommon in Texas to have what we call fruiting gaps, because that plant may have gone through a stress in the middle of the season. So you have bolls down here that are maturing, and you have a gap, and then you have new bolls setting up here. Like all plants, cotton pulls up its nutrients from the soil, and we can see some soil left on here and the way these roots are intertwined into that soil. The major thing that the plants take up are water, and most nutrients are actually traveling with the water into that plant. So as that plant takes up water from the soil, then it takes up the water and the nutrients come up here, and then literally the water is coming out of the stomates or the stomata on the bottom of these leaves. So it's pulling it up, and then it's actually being transpired out through those leaves, but the nutrients are staying. So that's how you get a lot of your nutrient uptake into that plant, is the water up through the stems and into the leaves of that plant. And then these leaves basically feed these bolls. So you have these primary leaves closest to the bolls. Those are the ones that primarily mature that boll along and keep it going. And it's no different than really grain crops. The top leaf right above the ear on corn, or right around the ear on the corn, or right below the head of wheat, that feeds primarily those grain. And cotton is really no different. So you have your nutrients like nitrogen, phosphorus, potassium, calcium, magnesium moving up through the roots and into the plant. And then you have your sunlight coming down that's creating, and carbon, CO2 going in through the leaves. That's creating those photosynthesis which is allowing it to create sugars to feed those bowls and additional vegetative growth. Sugars are the energy source, along with proteins and other things that are developed through enzymes and other metabolic processes in the plant.
Burr?
This is the bract. These are the bracts, and then the burr will be once this opens up. These are the nodes that are between each branch on the cotton plant, and that's this length we call internode length. So when we apply things like plant growth regulators, it actually prevents these from growing as much. So here's an example. This plant was growing really well, based on the length of the width of my fingers there, and the internode length represents kind of how it was growing, how vigorously it was growing. So good growing conditions, and then here you can see the internode length is still fairly wide, and then here we're down to 2 fingers. So probably at this point in time, just prior to this, we actually applied a plant growth regulator, which shrunk the internode length and prevented that plant from getting as tall. And then here, you can see it's starting to get a little longer and a little longer as we grow up. And then here, we probably applied it again, and that internode length isn't quite as long there. And then as you get further to the top, as you get more of a fruit load, that internode length will also start to shorten. So we talked a little bit about how cotton can compensate for lower plant populations. This is an example that you can see the number of fruit that it puts out on a plant. If you have a really high plant population, nearly all your fruit will be on the first position or second position of this branch. But if you have good growing conditions, it'll continue to put bowls out on the third and even fourth position bowls. So if you have plants that are really spaced out far, basically you get more bowls produced per plant, which then kind of equilibrates the yield if you have a lower plant population.